Hi everyone. So I wanted to give you just a quick summary and tutorial on all of the stuff we've been doing over the last couple days with quadratics. I'm kind of using this chart to summarize everything that we've talked about so you can kind of wrap your head around what I'm asking you to do and why. So when we're talking about quadratic equations, there are two forms that the equations come in. They come in vertex form, which looks like this, and they come in standard form, which is all simplified and nice, and it looks like this. And there's also two kind of key pieces of information we're always interested in when it comes to quadratics. The location of the vertex and the location of the zeros or the roots. That's the places where it crosses the x-axis, okay? And I'm just going to quick sketch up here a happy little parabola, just so you keep in mind that that's really what we're talking about. All of these are in reference to different parabolas, okay? So depending on which form you're in, the method of finding these two things is quite different, okay? When your equation is in vertex form like that, the vertex, as I hope you figured out, should be really easy to find. It's really just the h and the k from the formula up here, okay? You do have to watch out for signs. I'm going to just make a note here. Watch for your negative signs, okay? Because the signs of h and k, if you notice from your equation, are always going to be opposite from what they look like. If it was a positive 5 sitting here, but the equation has a minus in it, you might think that that's a negative 5, but it's not. It's just a positive 5. And when we do an example, I'll point that out, okay? To find the roots from this form, you have to plug in 0 for y, and solve. And that solving is always going to involve taking a square root at some point. Okay, you may have to divide by the a value first, and I'll point that out when we do an actual example. But when I say solve, I'm not talking about simplifying and foiling and all of that. I'm talking about working it backwards and getting rid of that square. Okay? When we're in standard form, we can find the vertex by using this little formula for h. It's negative b over 2a. And then your k value comes from plugging h into the equation. And the equation I'm talking about is the original one you're given that's in standard form. Okay. When you're in standard form, the roots come from the quadratic formula. So my goal for you is for you to become a flexible mathematician, meaning I want you to be able to do all four of these things very smoothly. Okay, so I could throw any equation at you and you would have at least one survival strategy, maybe even two. Okay, because on top of knowing how to do these four things, which is one of our standards that we're trying to address, I also want you to know how to convert back and forth between standard form and vertex form. So to get from standard form to vertex form, that's where we're using completing the square. Okay, so what we've been doing so far has been completing the square and turning this standard form into vertex form. You can also go back the other way, and let's see where I want to write this, maybe here. And that's a lot easier. That's just simplifying and doing like FOIL and distributing and things like that. Simplifying, and I'm just going to put here that really involves FOIL. Okay, so that refers to this arrow, not to, that box. So our standards, what we're trying to address right now is being able to do all four of these things, plus being able to go back and forth between these two forms. Okay, that's our goal for you. And so the day one homework that you had yesterday had you taking equations that looked like this, converting them to vertex form, and then doing these two processes, okay? Today, you're taking those same equations in standard form and finding the vertex and the zeros using these two processes, okay? So I'm going to do one of each. I'm going to do one of everything here so that you get an idea of what I'm asking of you and what you'll be asked to do on your quiz. So I'm going to take the very first problem from your homework. So problem number 1 from both the day 1 and the day 2 assignment looks like this. I'm going to replace it with y's and x's though, because I think some of us are getting bogged down by the different letters. X squared plus 2x minus 3. And what I'm about to do is what the day 1 assignment was asking you to do. Okay, so this is day 1. We wanted you to take this thing in standard form and convert it to vertex form by completing the square. So the first thing I want to do is move that 3 out of the way. I'm just going to slide it over to the other side. Okay, and then we want to put a mystery number in right here. We want to add in a number here that's going to allow this to be a perfect square trinomial. And the way we come up with that number is we take this middle number, divide it by 2, so we get 1, and then we square it, so that becomes a 1. Okay, and we talked a lot in class about where that came from, so if you need to review yesterday's lesson on why we're doing that process, please feel free. But then remember that mathematically, if I'm going to add 1 over here, to keep things balanced, I need to add 1 over here. So now my equation looks like this. Y plus 4 equals, and then this thing right here is a perfect square trinomial. That means I should be able to write it as like x plus or minus something squared. Okay, and this one would work out to be x plus 1 squared. If you're not sure where I got that from, again, we talked about that yesterday. You can also think about foiling this back out, x plus 1 times x plus 1, and it would turn back into this. Okay, so now we're in vertex form. That was our original goal, is to get this thing into vertex form. That's completing the square. And now I want to show you how to find the vertex and the roots, all right, from this form. So the vertex should be very easy. The vertex is just h and k. Okay? The one thing you have to look out for, if you look back up at what vertex form is supposed to look like, the h and the k are really supposed to be negative, okay? And they're positive here, which means that really what's going on is this is like a minus negative 4, and this is like a minus negative 1, to put it back in the form of the original equation. So my vertex would be the h value and the k value, so it would be negative 1, negative 4. Okay, that's the coordinates of the vertex. Now to find the roots, otherwise known as the zeros. I think on your homework assignment I called them the zeros. So to find the roots, we are going to take this equation in vertex form and we are going to plug in a 0 for y. Okay, so that's really going to look like this. 0 plus 4 equals x plus 1 squared. And I don't think you would normally have to write out this step, but I wanted you to see that I was plugging in a 0 here. Okay, so because I'm plugging in that 0, really what I have here is just this. 4 equals x plus 1 squared. To get rid of that square, I'm going to take a square root and take a square root. And the big key here is to remember that when you take a square root, you get a plus or minus answer. And then over here, this would just be x plus 1 now. Okay, but that plus or minus is very, very important because if you don't have it, you're going to miss one of your 2 answers. Okay. From here, I should be able to say that I have 2 separate equations. I have x plus 1 equals positive 2, and x plus 1 equals negative 2. And then when I go to solve them, here I end up, if I subtract 1, I get x equals 1. And here I end up with x equals negative 3. Okay, so just so you can see where my actual answers are. I kind of got mixed in there. X equals 1, x equals negative 3. Okay. So that was the day one assignment. It wanted you to go from standard form to vertex form, wanted you to find the vertex, wanted you to find the roots. Oh, and it also did want you to graph. Okay, so just quick here. If I was asked to graph something like this, and I'm just doing a real rough sketch here, I would graph where the vertex is located. So let's see, -1, -4 would be, I don't know, here-ish. Okay. And then the roots would be at +1 and -3. So here and here. And then you just want to connect those. Okay, and make your parabola. And to check and see if you got it right, the vertex should always end up falling kind of halfway between the two roots. All right, so if it ends up somewhere else, you know something's wrong somewhere. Okay, so that was problem number 1 all the way through from the day 1 assignment. Now I want to do the same thing from the day 2 assignment. So it was that same equation, except again, I'm using y's and x's instead of the a and the f of a. So y equals x squared plus 2x minus 3. Okay. And based on how it's written on your assignment, first it tells me to use the quadratic formula. Oh, find the vertex first, sorry. So for part A, it wants me to find the vertex. Now, when it's in this form for finding the vertex, this is where we're going to use this little formula. H equals -b over 2a. So we would say -2 over 2 times my a value of, remember there's really like a 1 there, okay? So -2 times 1. That's really -2 over 2, which is -1, okay? And then to find k, I'm going to take that -1 that I just found and plug it in up here for x. So I'm going to go -1 squared plus 2 times -1 minus 3. So that's, let's see, +1, -2, so that's -1 minus 3, so that's -4. And then we want to put those two things together as a coordinate. So that would be -1, -4. And if you refer back to what we just did, that's the exact same answer we got for the vertex before when we put it into vertex form. Okay? Okay, so that was the vertex. Now we want to look at how to find the roots, and that would be using the quadratic formula. Okay, the roots, here's the formula. X equals -b plus minus square root b squared minus 4ac all over 2a. So I would say x equals -b, so -2, plus or minus the square root of 2 squared minus 4 times 1 times -3, all over 2 times 1. I would dive in right here. I would start with this number here. Okay, so that's 4 plus 12, so that gives me a 16. So this is -2 plus minus square root of 16 over 2. From here, I've got the plus minus, and I kind of ran out of room going this way, so I'm just going to kind of go over here. Maybe I'll rewrite real quick. You wouldn't normally have to rewrite this, but over 2. We're going to split into 2 separate problems, and I'm going to go ahead and evaluate the square root of 16. So I'm going to say -2 plus 4 over 2. And then down here, -2 minus 4 over 2. Now, if I were you, I would just trust your brain here because I see problems when people put these things into their calculator. But -2 plus 4 is +2. So this is really 2 over 2, which equals 1. And then -2 minus 4 is -6. Over 2 is -3. Okay. And those there would be your two roots. So again, if you looked back at the problem we just did a second ago, on day one, we got these same answers, but now we're just talking a different process. This is much more about the process than the product. All right, let me just write up here that this is what I'm looking for day two. Okay. Your quiz is going to make you do this exact thing. So it's going to give you an equation in standard form. It's going to make you do the vertex this way with the negative b over 2a. It's going to make you do the quadratic formula. Then it's going to make you convert to vertex form and find the exact same things using the vertex and the roots. Okay? Or sorry, using, the h and k and then plug in for 0 and solve. That's what you're going to have to do for this quiz. Okay? The good thing is, because it's all the same equation, just like we did here, the same equation for both, the answers should all come out the same. So you do still have to show me all of the steps to show me you know both processes, but you should be able to check yourself and make sure that your answer came out the same way both times. Okay? Okay, so we will have another review day in class tomorrow, but I just thought that might be a good summary of everything, and if you were struggling with the homework, hopefully that helped a little bit.